in last lecture, we have deployed Faucet smart contract to our private Ganache blockchain. In this lecture, I will be explaining some additional informations about the transactions. So again, this lecture will be additional information lecture, AI lecture. It's free to skip. So if you feel like that you have enough information about the transactions, go ahead to the next lecture. Okay, so for those ones that are staying here, let's see our transactions we have made and let's inspect our latest contract creation transaction. So let's click here. It is also a transaction that has created, deployed our Faucet smart contract. So we have here transaction data, which is a bytecode of the smart contract. Also some details as a sender address. So that's our account address from which transaction has been initiated. That's a by default first address from all these addresses provided by Ganache. Okay, and what have here else is a value. So we can also send some if along with the transaction. We are not sending any. All right, and also we are specifying gas use, gas price, and a gas limit. And actually, I would like to talk about these things here: gas use, gas price, and gas limit. So for every transaction on a blockchain, you have to pay. When you're making transactions, you have to pay for a transaction. This makes also incentive for miners to mine the transaction. So they are choosing by default a transaction which has a bigger value because you can imagine that in the Ethereum. Let me get into drawing tool. In Ethereum, you have a lot of transactions, right? In the mempool, you have a lot of transactions. Okay, you have thousands of transactions. There are transaction, and every transaction does something else. This transaction, for example, is sending some Ether from account to account. This transaction is calling some smart contract. This transaction is transferring some money or converting some Ether to other currency, and so on. Every transaction is doing something else, right? But also along with this, every transaction has also some value, some gas price. So some price, some amount of the gas, and the value of the gas that the user is willing to pay for the transaction, right? So there is some gas fees, right? For example, this will not precise value. Let's say this transaction has a value of 0.0001 Ether. This is a 0.000 of 3 Ether, and so on. So every transaction has some value to it. So when the miner will picking up the transactions into the blocks, he will try to get a transaction with the larger values. Okay, so he will not get a transaction with a 0.0001, but rather he will take a transaction with a 0.003. Okay, so he will get this transaction into the block rather with a bigger value. So he will rather pick this transaction and he will order it into the block, right? Okay, and therefore when your transaction has a higher value, also it will be faster processed and will be faster resolved into the block. So for example, if you're sending money from account to account, this money to the other account will be sent faster because your transaction is not waiting here in the mempool until the miner will pick it up, but it's going immediately because it has a bigger value. So every transaction has also this value. Okay, so that's the one thing. Also, other thing is, for example, when you're making transaction, I will draw here. Okay, let me see. We have a transaction, let's say, to some smart contracts. We have here some smart contract on Ethereum blockchain. Let's say, and here is some hacker making transaction. Okay, here will be Mr. Hacker. And making transaction. He has also, of course, some address. Doesn't really matter which address is here. It says but he's basically making a transaction to access some function. So on the smart contract, some function on the smart contract. Of course, the transaction he has also specified the gas fee. For example, he will specify he's sending along with the transaction a gas fee. So the gas fee will be, let's say 2 ETH. That's too much, but doesn't really matter. A gas fee will be 2 ETH. So when he's calling a function, the hacker knows when he will call the function and he will send some value to the function, he can basically create infinite loop here. Okay, so basically he can create infinite loop in the contract. So therefore, this transaction, when this transaction will be executed on the Ethereum blockchain by the other miners, this means it will create an infinite loop also to other miners, and it can suck their resources infinitely, right? And they will be basically stuck in an infinite loop and it will be not stopped. But since we are paying the gas fees, this will not happen. No infinite loop happens because this price that we are sending along with the transaction is ensuring that at the one point the hacker funds, these gas fees will be drained. All right, because for every call of the function on the blockchain, you have to pay some ether. That's why you're saying this gas fee. So I'm sending here, I am willing to spend for this transaction to ether. So when I will create here infinite loop and I'm calling function, each function has some value. So let's say I'm calling here function, doesn't really matter. I'm adding here two numbers together. This costs some gas. So in the transaction here, I'm adding 2 plus 2, let's say, and this will be running infinitely. And for each execution of this code, I will pay 3 gas. All right, 3 gas. So when I will call it infinitely, this, in the end, I will reach the limit of this gas fee of to ether. And when this will happen, the execution will be stopped. Okay, so there is the upper limit how many functions we can basically call, because every function costs some gas fee. I will give you an example. When the miner will get a transaction and will try to execute it, the blockchain, here is the instructions to be executed. For example, here is the instruction 60. All right, the 60 is a push byte transaction. I will get into these details later, but note here that this is a code that has to be executed, is 60. And the 60 has some value. So here is a byte code, 60, is a push operation, and this costs 3 gas. So when I will create here this infinite loop, and I will be calling infinitely some instruction, I'll be calling infinitely instruction to push byte, okay, basically, or I will be adding 2 numbers, and I will be paying constantly 3 gas fees for this. I will reach the limit, and these fees of this hacker will be drained. Okay, so I will reach the limit. The hacker has to pay this 2 ether, even though this transaction will fail. All right, so he has to pay 2 ether for a transaction, so he'll be drained. He will have on the account now minus 2 ETH, and the transaction will stop. Then this 2 ETH will be drained. Because he was calling infinitely this 2 plus 2. Okay, he tried to hack the system, but since this has to be run, he wants to run it infinitely, but since he has to pay for each computational instruction, then in the end, his funds will be drained in the transaction, and his final ether he'll be deducted by 2, because that's what he set as the upper limit for a transaction. I know these things can seem a little bit confusing. I know, guys. So that's why we have these gas limits. It's as an incentive for the miners, and also anti-hacker stuff, because you have to pay for the transactions. You don't want to really do some hacky stuff or to introduce some infinite loops when you have to pay for it, right? So that is not really worth it. Okay. Also, other thing I would like to explain you, but I think I will leave it for the next lecture. So we'll be talking exactly in what units is this? Is it ether? Is it something else? About these guys in the next one. If you have any questions, just feel free to ask them, and I hope to see you in the next lecture, guys. Cheers.